All right, so yesterday we went through and explored and saw that atoms were composed of protons, neutrons, and electrons, and then also that those numbers of protons, neutrons, electrons can affect the atomic mass as well as the charge. So what do these numbers mean? We kind of, there's multiple ways to look at and to signify an element and its mass and to write out how you can write those things out. And so in looking at this periodic table, we can look at any of these elements. So let's look at the example. Mercury. Mercury's name is given. The name is given. The atomic number is given, which remember is the number of protons. The symbol is given, and then the average mass. And so another thing, just to kind of look at it, when you have the atomic number, if there's no charge on the element or ion, you would have protons is equal to electrons. So the proton number would be equal to the electron number. So if I was going through here and I asked you how many protons, you'd say 80. How many electrons? You'd say 80. And then neutrons, if I was asking you neutrons, how many would there be? Well, you can look at this. It says 200.59. So the weird thing here is that it's not a full number. It's the average mass. So why is it 200.59? Well, we can figure out that on average, the mass of Mercury is between 200 and 201. So, well, first of all, let's figure out how many neutrons is this. So remember, protons plus neutrons is going to give you this atomic or average mass. So the mass. So if you were to do this, you could say protons, which is 80. So I did 80 protons plus my neutrons is 200.59. So if you look at this, your neutrons is typically 120.59. So in other words, it's around 120. You could say 120.59. So why is it not a full number? Because you can't have 0.59 proton or 0.59 neutrons. The reason is that it's the average. So in other words, you could have in nature, in real life, you could have around 120, 121. And so depending on the time that you have, let's say 121 neutrons, and you look at the amount of time you have 120 neutrons, those relative times and how much we see them in nature are averaged out, and that's given your average number there, 120.59. So if we're looking at different elements like carbon, so here's our carbon. I kind of just go through this with you guys. Carbon here, that's the element name. This 6 is the atomic number, which is also the number of protons. So if I was to write out the protons, you would say 6. If I was to write the electrons out, I'm going to say, 6, because there's no charge on it, so 6. Remember, there's 6 protons, which are positive, 6 electrons, which are negative. That charge balances out. Then I'm going to look at the average mass to figure out the neutrons. And so neutrons are going to be protons plus neutrons gives you the mass. So 6 for the protons plus my neutrons is going to be 12.01. And so on average, I have 6.01 neutrons. So you're looking at that, you're like, well, why are you not using significant figures here? Because these are constants, and so it's assumed that that would be like that. So you're not too concerned about sig figs here. They're not calculations. They're basically constants that are always there. All right, so on average, you would have 6 neutrons in nature, but occasionally you might have 7 or 8 in real life. And so that 7 or 8 in real life makes that average to become 6.01. But more often than not, you have 6.01 neutrons for a carbon. All right, so that is how to read the periodic table. There's different ways, different formats to kind of look at writing and expressing elements. And so we'll get to that in a second. But just a couple of terms for you guys to be familiar with, something called an ion and an isotope. Ion is really simply varying number of electrons to protons. We'll talk about what that means in a second. So basically there's a charge on your element, and an isotope is varying amount of neutrons. So that would be just varying amounts of neutrons there. Let's go through a more robust definition. So what are ions? Ions, an atom is neutral. It has neither a positive nor a negative charge. In order for the atom to be neutral, the number of electrons must be equal to the number of protons. The positive and negative charges cancel each other out. If an atom does not have the same number of protons and electrons, an ion is formed. So if you have like a +1 or a -1 or a +3, those are all ions. So just a couple of terms I want you guys to be familiar with. A cation is a positively charged ion, and an anion is a negatively charged ion. So if I have like copper +2, you would go cation. Great. So here's some examples. Sodium plus, chloride plus, or Cl minus. Those are going to be cation and anions. That says anion. So those are some examples of ions. Now let's look at isotopes. So what are isotopes? Isotopes are all atoms of an element that have the same atomic number, so the same element, and have same number of protons, because if you change the protons, you change the element. However, the atom does not necessarily have the same number of neutrons. So that's what we talked about earlier with the average atomic mass is dependent upon the number of neutrons, which changes. And so depending upon the amount of time that you see one particular neutron in nature, you can kind of depend on the average mass. But atoms with the same number of electrons and protons but differing numbers of neutrons are called isotopes. So if you had something like lead, you'd have lead here. That would be, well, you would typically you'd see lead like 207. So this is the mass. That's the number of protons, or the atomic number. But sometimes you might see something like this, 211 lead with the 82. And so this is going to be your atomic number. That's going to be your atomic mass, which is dependent upon the number of protons and neutrons. So just some examples of some isotopes. You have isotopes of hydrogen. Hydrogen is the simplest element. It has, typically you'd have one proton and one electron. That's going to be hydrogen. If you add a neutron to it, then you have one proton, one neutron, one electron. That's going to be hydrogen 2. Now your mass is no longer 1, it's mass of 2 because you have one proton, one neutron. Continuing on, you have hydrogen 3, or tritium. You would have one proton. That doesn't change. If you change that, you change the element. One electron if it's neutral, and then 2 neutrons will give you a mass of 3. So depending upon this number here, that's the mass, that's the mass. That's just another way to write out what an element's isotope looks like. So those are all dependent upon the number of neutrons. So notice 1, 0, 1, and 2 neutrons can all be had with a hydrogen. So if I was looking at this, let's kind of walk through this. List out the number of protons, neutrons, and electrons. So protons is always going to be the same for Pb, which is the element lead. That is going to be 82, which is this same number here. If it is neutral, notice there's no charge. That's going to be also 82. Your protons and electrons are the same. And then this atomic mass, so 207 is the atomic mass, which is the protons plus the neutrons. So I'm going to add 82 plus my neutrons. Neutrons are going to be 125. So my neutrons here are 125. That would be how you kind of solve that. Let's do another example. So list out the protons, neutrons, and electrons. Sorry, these numbers should be like right here. It's kind of weird. This is Mn, manganese. So my protons are this number here. That is 25. My electrons are not 25 because there is a charge on it. And so if you remember our terms, the charge here is positive, so it's a cation. In essence, I have a +2 charge. So you may be thinking, how do I figure this out? If I have 25 positive electrons, how many 25 positive protons, how many negative electrons do I have in order to get a +2 charge? And so looking at this, what number needs to be here in order for us to determine a +2 charge? If I have 25 positive protons, I need 23 negative electrons. And so my electrons are negative, so +25 for the protons, -23 for the electrons. That would give me an overall charge of +2. If I was to have a charge of -2, then I would have two more negative electrons. So if, kind of just a rule here, if I have a positive charge, more protons, and if I have a negative charge, I have more electrons present. And the only thing we can change to make these ions, either cation or anion, is the number of electrons, because if you change the number of protons, you change the element. All right, cool. So hopefully that was helpful. There's a couple ways to look at different elements. Sometimes you might just see them as, hey, I tell you it's carbon, or I might write down it's carbon 14. So if it's just carbon, you assume the mass of 12.01 for the periodic table. If I write carbon 14, that 14 will be the mass. Sometimes you can write carbon with a 6, with a 14 there, and then maybe a charge on it. That would be all kind of different ways to signify and write out the presence of different elements. So hopefully that was helpful. We'll spend more time going through that, and I'll talk to you later.